Okay, this is 2.4 in your textbook, adding and subtracting polynomials. So they use algebra tiles in your textbook. I don't like using these a lot, but I want to teach them just so that you're comfortable doing the homework. All right, you don't necessarily need them. You shouldn't need them on my test. I won't include a lot of these questions, but you should know how they work anyways. So they use red tiles to represent positive integers, and they use blue tiles to represent negative tiles for integers. Okay, so we use this stick as x, that same kind of dimension, that same height, squared as x squared. Y is a little bit shorter, so y squared is a little bit smaller. And then finally the number, or just the integer 1, is very small, and the number xy is a rectangle, because obviously the side, one side length is going to be shorter, y, and one side length is going to be longer, x. Okay, so if we have a mixed variable, xy, it's this tile. If we have the number 1, it's this tile, and so forth. Okay, the same thing goes for negative, except for they're blue. All right. So when we have questions in the homework that says draw an algebraic tile representing 2x squared minus x, we need to draw 2x squared. So if this tile represents x squared, we need to draw two of those big tiles in red because it's positive. That's 2x squared, and then minus x. So minus x is blue. It's this little rectangle here in blue. So that would be this color. Okay, so that drawing then would represent 2x squared minus x. Similarly, 2y minus 2x. So y is a little bit smaller, so there's two of them. So you have 2y minus 2x. So x is this taller one in blue. It's negative. Plus 2. Now integer is just this small square. It's positive, so it's red. Positive, positive. Okay? Any questions there? All right, so now it says write an expression for this. Well, these are the same size as y, so in this case we have 2y squared. Two tall rectangles. These are xy, so we have 2xy. Again, it's positive. And then finally, three large blue squares represents negative, so we have negative 3x squared. All right, so that would be your expression for those tiles. Similarly, here we have negative xy, so we have negative 3xy. We have a positive, just the integer 3, and finally on the end, positive, and that would be 2x squared. Okay. Just listen up, guys. I'm just going to finish up here. So finally then, we can add, like terms can be combined by adding or subtracting their numerical coefficients. When I say numerical coefficients, what I'm referring to is a number in front of the variable. Okay, that's your coefficient. All right. So if we wanted to simplify a term like this, the first thing we want to do is to get rid of these brackets. Okay, the way I do that is I have to distribute this negative sign to both terms inside the bracket. So it works like this: 2y minus 2x squared minus 3y minus 4x squared. Okay, so now the bracket is gone. Guys, hold on. Just wait 2 seconds. Don't pack up, please. Once the brackets are gone, now I'm going to gather like terms. So everything that has x squared, I'm going to put together. So negative 2x squared minus 4x squared. And the last two like terms, I have positive 2y minus 3y. So if I gather these, negative 2x squared minus 4x squared, I get minus 6x squared, and then minus y. Because we get positive 2 minus 3 is minus y. So there's my final answer. Okay? All right, that's the end. Thank you. Oh, yeah.